Perfect. I'm Chris Bays. I'm the president of AACE this year, and we have Mario giving a presentation on what non-schedulers should know about scheduling today. Mario has a very interesting background, starting in the software world, working for Oracle at the Primavera team for several years. And then he jumped out to Jacobs, working on the HART project and getting into industry. So I think he has very well-rounded experience. I certainly look forward to listening in today. Thanks, Mario.
All right, thank you, Chris. I appreciate it. Let me go ahead and share my screen here. And hopefully you guys are able to see. You should see a P6 screen.
Yes.
Yep, we're good.
Yep, okay, good, excellent. Okay, wonderful. So quick introduction here. So I appreciate that. Thank you, Chris. My name is Mario Flores. For those that don't know me, like Chris said, I've been here on the HART project since I moved to Hawaii from Philadelphia in March of 2020 to start this job. And I don't know if you remember what happened in March of 2020. So yeah, that was kind of an interesting time. But I've been doing scheduling here for the program since then in a project controls capacity. So I figured for this session here, we want to try to keep it informal. This is not about making you guys into schedulers yourselves. It's not about me teaching you how to use P6. I don't want it to be a super formal presentation. We just thought, scheduling is such a kind of a niche profession for people that don't really understand it. When in reality, perhaps I'm biased, but a schedule can have, quite a big impact on other roles that are surrounding project delivery, project management, or what have you. So we thought this might be a good time to introduce some schedule ideas, some schedule concepts that are really important to keep in mind, and also talk a little bit about what a schedule could impact even for your role if you're not a scheduler. Like if you're coming from the cost world, you're an estimator, maybe you're, my perspective here from HART is we're obviously the owner, but if you're a contractor, right, the schedule is obviously super important for them as well. So just wanted to get into a little bit of those topics. I do have one PowerPoint presentation, and that's kind of the only formal part. The rest of it, I would certainly love if you guys have questions, just come off mute if you're comfortable doing that. If not, please post it in the chat. We have Chris, we have Vince in here to monitor the chat. And if a question comes in, please stop me, guys, and let me know. But otherwise, yeah, I just have a bunch of cool stuff I think is cool at least that I want to walk through and kind of put it out there about why scheduling is sort of more important than you might otherwise think. So with that said, I do want to show just kind of a preview of where we're headed in this presentation. So this PDF that I have open here, this is one complete schedule, one of our schedules here at HART that is in progress, and this is kind of what we're heading towards here. There's about 1,100 activities in this schedule. Some progress has already been made. Let me come down to a couple of activities might be interesting here, right? So here for, depending on the industry, this might be familiar with it, but we have activities here for delivering potholing out on the street before beginning jack routing and then doing utility relocations and installs. We have a couple of different headings of the types of work that's going on. Here's some sewer line, here's some electrical and telecom, some street lights, traffic signals. Whatever the types of work are, we have this all categorized and grouped out and listed here, right? So this is a full, complete schedule. This is where I want to take you guys here in this session. So first things first, I want to start with what is a schedule, right? What is a schedule? There's a lot of different definitions depending on who you talk to. The way I've always thought of a schedule in my previous world and then also coming here to HART is think about the work that has to be done on a given project, right? So you're building a house. I'm not a home builder, but at some point you're probably going to have to do some excavation. You certainly are going to need to pour your foundations. You're erecting your frame. There's some exterior finishes and interior finishes need to go in. You've got plumbing and electrical hookups that have to happen. There's lighting, there's fixtures, you got your cabinets, you got flooring, you got windows, you got roofing, right? There's all different things that need to happen in order to construct that house. And the things that you need to do, right? What needs to be done and how it should be done. That's your plan, right? That's based off of your designs and your drawings, and that's the plan of how this house is going to come together. But when are you going to do those things? What happens first? What happens after that? What needs to be done before we can move on to this next thing? Who's going to be involved in doing that construction? What resources do we need? How much is it going to cost at certain points along the way? Is there a more optimal way to sequence that work to reduce the overhead, let's say, or increase the efficiency and productivity? That part is a schedule, right? Depending on the industry, depending on the project, some of those details can change, but generally speaking, that is a schedule, right? And that's what I want to take us towards here. So we did a quick preview of a schedule output. Now I want to take you into a math lesson, which is my presentation. This is how you can build a schedule. Yes, there's going to be a little bit of math, but it's not a lot, just a little bit. So let me go ahead and share my presentation here, and we'll go through this. I used to, back in my previous job when I was with Oracle, I did training classes on Primavera P6 specifically as a scheduling software, but this is essentially, if you've done anything in scheduling in the past, if you've taken training courses on scheduling, what I'm about to go through is going to be very familiar to you, all right? So just a heads up for my schedulers that are joining us in the audience. So what non-schedulers should know about scheduling. I have my little handy helper here with me, so he's going to help us walk through a quick little example about how a schedule comes together, right? So first things first, to build a schedule, the sort of the fundamental building block of any schedule are what we call activities. Depending on your background, you might call them tasks, but we have activities, right? These are the individual things that need to happen in order for this project to be successful, right? We're going to have to excavate. We have to form and pour a foundational slab, right? Architectural slab. We have to install window frames, right? Whatever the activity may be for the project that we're working on, those are going to be identified as activities. That activity is then going to be given a duration. So in this case, for my example, activity A, let's say, whatever this activity is, it's a 10-day duration activity. For activity B, that is a 5-day duration activity. And then finally, we have activity C as a 10-day duration activity. Okay, so simple schedule, super plain and straightforward. We got 3 activities. This is our project, all right? So from here, there's something missing, right? There's something missing. These activities in and of themselves, it's just a list of work that has to be done, right? What's missing that can turn this into a schedule are what we call relationships or logic ties, depending on where you're coming from. So what relationships are the interdependencies between activities, right? What's the sequence here? What has to happen first? What comes second? What can happen in parallel with other work, depending on the nature of the work that you're doing. And we identify those relationships as predecessors and successors. What happens first? What happens after? And so in the situation,
Mario, you're on mute.
there, am I back?
Yeah, I can hear you now. Thanks.
Okay. Oh, that's weird because I didn't touch anything. Did somebody mute me accidentally? Huh.
Yes,
I
that was
just
me.
couldn't hear you.
Sorry.
Oh, okay. No worries. Hey, we're all friends here. It's all good. Okay. Right. So, oops, that doesn't go there. All right. So now that that's going, all right. So back to where I was saying. So the predecessors that we have here, activity A and activity B, according to the logic that we have set up, these blue arrows here in the middle, we're saying that activity A and B both have to be complete before activity C can start. Right, so simple logic. Once A and B are both done, then we can do C. Right, pretty straightforward. So with this, now we're able to begin the process of scheduling. right? And all of these terms like predecessors and successors, and here data date that I'm about to explain, the terms are not what it's important here. What I want to do is demonstrate how a schedule comes together. There's a couple of concepts at the end that are going to be crucial for the rest of this, right? So here, we're ready to schedule. When a schedule is calculated, it's always going to be calculated by what's called the data date, or time now. So whatever the date is of your data date, all of your remaining work is going to be scheduled forward from there. So today is what, December 16th, right? So let's say today's December 16th. Activity A is 10 days in duration from December 16th. So 10 days from now, let's call it business day. So 2 weeks from now, two Fridays from now, the activity A is going to be done, right? According to the schedule. Same for activity B, and then so on. Then we can calculate activity C. Yeah. So those calculations is what we call the forward pass. Starting from the data date with the activities that are that don't have any other predecessors, right? A and B have no predecessors in this case. We can schedule them forward to calculate what are called the early dates for our project, which is really just what's the earliest that each of our activities can start and finish in order to determine the duration of our project. So for activity A, that's pretty simple. The earliest it can start is on day 1. It's a 10-day activity, so it's going to be finished at the end of day 10, right? Easy. For activity B, same thing. The earliest it can start is day 1 and has a 5-day duration. So the earliest that it can finish is going to be at the end of day 5. Now, something to think about. In this case, what's the earliest that activity C could start? Right, it's got 2 predecessors, activity A, activity B. What we said before, the predecessors have to both be finished in this case before C can start. So the earliest that C can start is going to be on day 11, right? Because even though B is done day 5, A is not. It has to wait for A to be finished. That's why it starts at the morning of day 11. Yep. And then it's another 10-day duration activity. Easy enough. It finishes at the end of day 20. So that being said, because C had to wait until activity A was complete, that gives us something that we call the driving relationship, which relationship is the reason that activity C is scheduled to the date that it is. In this case, that's going to be activity A. Activity A is the driving relationship, as you see by the solid line, right? As opposed to this dashed line from activity B, letting us know that yes, B has a relationship to C. It certainly has to be done before C can begin, but it's not the driver. That's not the reason that activity C is scheduled to the date that it is, right? So that's the forward pass. Altogether, this project starts on day 1, we schedule it out, ends at day 20. Yeah. Really, when we jump into P6 here in a minute, scheduling software or Microsoft Project, if you use that, Acumen Fuse, whatever scheduling tools that are out there, all they really are just big, giant, fancy graphical calculators, right? They just do a whole bunch of math behind the scenes to determine where activities are going to fall on your schedule, right? That's basically what we're doing here. So forward pass, we calculate the earliest that activities can start and finish. Then from there, we want to determine, okay, what's the latest that activities can start and finish without delaying the project, right? That's what we call the backward pass. It's the same set of calculations, just going the other direction, starting at the end of the project, calculating all the way back to the data date. Right. So in this case, because we haven't, let's say we haven't inflicted a deadline on the project yet, you have as long as you want to finish. Well, we know the project is finishing on day 20 currently, so that's where we start the calculations on the backward pass. Yeah. So the latest we can finish is day 20 because that's the date we're scheduled to finish anyway. Then we just do the math backwards, right? 10-day duration activity from day 20 means the latest that activity C can start is day 11. And with now going backwards, remembering the relationships that we have, if activity C, the latest that it can start is day 11, what would be the latest that A and B could each finish? Well, by extension, it would have to be day 10, yeah? Activity A or B couldn't finish any later than day 10 without delaying day C. So that's where we start the calculations for not just A, but also for B, right? So the latest B can finish is also day 10, and it only has a 5-day duration. So the latest it can start is as late as day 6. Yeah, pretty interesting. A little different calculation there, right? So at that point, your scheduling is done. Yeah, if you're ever working in P6 or Microsoft Project, you hit the schedule button and it calculates everything. This is what it does. Forward pass for the early dates, backward pass for the latest dates. Early is the earliest things can work. Late is the latest they must work without delaying the end of the project. And that's it, right? But here's where something interesting comes in. This is the part that I wanted to get to. For each of these activities, we can calculate something that we call float. Yeah. So I'm going to give my little helper a coffee break here, and let's calculate float. Float is the amount of time that an activity can slip from its early dates before it impacts the end of the project, its late dates, right? And so really the calculation of float is just the difference between the early dates on the bottom and the late dates on top. So what's the difference between the two here? Obviously 1 minus 1 is 0. So this one has 0 days of float. For activity B, 6 minus 1 gives you 5. So this activity actually has 5 days of float. And then you do the same calculation for C and you have 0 days of float again. So this sets up something, once you understand the idea of float, how much time can a single given activity slip before it impacts the end of the project? That is called total float. There's other types of float like free float, but I don't want to complicate things here. So the float of an activity is how much slip that it has. And by understanding the float, that's where you can calculate what we call the critical path. And the critical path is probably one of the most important concepts in scheduling, because that's going to determine what your end date of the whole schedule is, right? If you start from day one and just follow the critical path, that's going to lead you to the end of the schedule. So in this case, just understanding, 0 days of float on activity A and activity C, we have 5 days of positive float on activity B. So our critical path is going to be A to C. Right? Seems pretty obvious, right? And it's simple, straightforward, but expand that out times 1,100 different activities that all have different durations, and there's different relationships, and some have deadlines that are placed on them, and all other sorts of stuff. Yeah, it can get pretty complicated. That's typically what a scheduling software is for. But all that scheduling software is doing is exactly this. That's why I wanted to take a little bit of time to kind of go through this in detail, because the concept of a critical path, the idea of the float values, those are some of the most crucial underpinnings of what a schedule is in terms of scheduling. There's other things that result once you have a schedule that I'll get into as well, but this is the foundation I wanted to make sure that people take away. All right. So that is my PowerPoint presentation. Like I said, there's a little bit of math, but it wasn't too painful, right? Pretty straightforward. So once you're there, you understand how activities work together. You have your relationships. We understand the forward pass and the backward pass. Just kind of a little sneaky thing here. I built all these activities for my presentation in P6 because I can now schedule these. I have a bunch of activities. You can see I have all these relationship lines between them. So if I hit F9 and schedule this, it's going to go ahead and schedule these activities just according to the durations that they have, the calendars that they're assigned on, the relationships between them, and here you go. So this presentation is apparently going to take us until November 17th in the past, right? Just scheduling from the day to date. So, I mean, don't put any stock in the dates here, but just this is what P6 does. What we just did in PowerPoint, there it is. It just runs the math in order to calculate the schedule. Cool. So let me come back to my next section here. So understanding the idea of a critical path, like you can see this is a critical path here in just this sort of simple list of schedule of activities that I have here, but you can have more than one critical path depending on the nature of the work that you're doing. Yeah, especially here at HART, because we're such a large program, we tend to have multiple critical paths, and that idea is something to be able to keep straight. So let me jump into. I have another project I want to open up here. Right one. Let's open up the schedule. So what you're seeing here on my screen, this is just a copy of all of the HART schedules that we maintain here. I've done some kind of tweaking with them, so these aren't the literal schedules, obviously, because I didn't want to give away things that I'm not supposed to. But so this is kind of an approximation of a live schedule that we maintain here. This is the City Center Utilities Relocations project that is going through downtown at the moment. That's underway as we speak. And I can open up something like, so this would be the full schedule for that project, right? We have some pre-construction work, obtained permits, and pre-NTP submittals. Don't worry about those. And we have some initial construction, setting up some temporary ITS, intelligent traffic systems. We're doing some sewer line work on Ka'ahi Street. There's electrical and telecom work that's going to happen after that, street lights, and et cetera, right? So with all of this scheduled, you'll notice I have here the column for total float, right? And that total float, like we just saw, is at least initially, that's the determining factor of where the critical path lies, right? So in a view like right here, you can already see I have some of these zero float activities. You see the red bars in the bar chart over here, and then some activities with positive float that are shown up in green. Yeah, easy enough. In a software system like this, maybe not so much in a PowerPoint, but on a software system like this, it's pretty easy to change up your view and just focus on, show me just the critical path for now. Let's see what's actually causing my schedule to show to the date that it is. So let me change my view. And now we're filtering to only the critical path activities, right? So you can see that the critical path in this schedule, right, flows through all these activities here, the sewer line work, and then into electrical work on NIMITs, and then, finishing up with some HECO installation, some electrical duct banks and jet grouting on Hollywood Street, right, before final closeout and project substantial completion. Yeah, so this being the critical path, if I were managing this project today, and yes, I am, this is where we want to make sure that the contractor performing this work is focusing their resources, right? Because this is what's contributing from what is this? From the day that this activity started, back in October until the day that it's supposed to finish, right? And you scroll all the way through to the day that it's finishing. Here's the final completion of the project. What's getting us from point A to point B? These are that set of activities. There's 70 something of them, right? So identifying and tracking towards and sort of maintaining and staying on top of your critical path is crucial to being able to identify when a schedule is supposed to finish. But also keep in mind, like we just showed a second ago, let me take that filter off. There is other work that's happening at the same time. All of these green activities. Like here's a perfect example. This road restoration at the completion of the Halakawila work. Someone still has to do this, and we see when they're supposed to do it. They just have 84 days of float, meaning they have 84 days from the day that they're scheduled now before they would become critical themselves and take over the critical path. That's what the total float is telling us. Right, but we can take this to the next step as well. Let me grab a couple of other schedules here. And I want to take it one step further. Let's grab this, grab this, grab this. Yep. So that was just one path, just one critical path for one schedule, right? We also can show something that is a little more of a step up, but is equally important. Not just the critical path, but what we would call a near critical path as well. Because staying on top of the critical path is obviously the most important thing right now, because that's what's driving the end date of your project at the moment. But anything that is near critical could become critical fairly soon. So let me show a different view to display that. And so you end up with a view like this. This is the work that's happening out on the airport segment of HART. We're in the middle of doing core systems installations on some of the stations out there. So, and that's the critical path right now for the airport segment, right? You have all this core systems work, installations, testing, cable pulling, train testing, et cetera, all the way until, let me fix this part of the screen, all the way until we reach the end, and then airport section, segment 2 we call it, is ready to go, right? Operational readiness, and there's the end date. So that's your critical path. You see the total float is 0. But this next path, right, path number 2, right, this is the near critical path. You see it only has 12 days of float in this example, right? So that's saying, these cable pulls and cable tray installations and the comms installations that are down here, like all this work, this only has, a little over 2 weeks if you're counting by business days, right? That's, only, 2.5 weeks of float that if, say for whatever reason, install cable trays, let's say the cable trays didn't get delivered to the island in time. There's a shipping delay or fabrication delay, whatever, right? And so that's going to get delayed a month, right? If this activity gets delayed a month, this becomes the new critical path. And I know that because it only has 12 days of float. Right. So this is the kind of the thing that, as a scheduler, that I would stay hyper focused on. Obviously, the critical path is the most important right now, but just making sure that, the decision makers, project managers, your resident engineer, field inspectors, the contractor, whoever, just make sure that they're aware. Okay, yeah, we have that as the critical path, but how are things going with, the material deliveries for the near critical work, right? Or if any of these, comms cables not getting delivered in time. Right? Because that would then impact the near critical path and could potentially make it critical. Right, so just a couple of different things there. One last example that I'll show before we move on to a different topic. Let me grab a couple of these and a couple of these. Give these a chance to open here. These are pretty large schedules, so this might take a while. But what I want to be able to show is, like I said before, you could have more than one critical path. And as you can see here, I'm opening multiple projects at the same time. So let me go to this view here. So I have like 5 or 6 projects all open at the same time here, right? And I have a critical path, right? This is a critical path that's, showing all the work that happens to be the city center alignment of work. So, utility relocations and constructing the guideway, building stations, core systems, et cetera, right? So this is the critical path to the end of, essentially, this is to the end of the entire program, right? Till HART is complete and all of the rail is finished. This is what this portion of the schedule is showing here. But this one critical path is actually cutting across multiple individual schedules themselves, individual projects in their own right that have their own critical paths, right? So let me throw, oops, not this one. Let me throw one thing in here. All right. So if I just throw another level of grouping here, so I have my critical path denoted by the number 1, but I see that I also have work happening in multiple individual schedules that in and of themselves, if I were to look at their own critical paths, they would have their own critical path, right? Outside and above the overall critical path for everything, right? Each one of those schedules has their own critical path, and they could be completely different, right? Like, in fact, it's definitely different. You know what I mean? So like for instance, for the critical path for the city center guideway and stations, that's going to run through a different station, a different section of that segment than the overall critical path does to the completion of HART. And it's just, the way that the dates roll out and the interconnections with the core system schedules and all the rest of it, right? The details here don't matter. I'm just trying to get the point across is that you might have multiple critical paths depending on the content that you're working with. Yeah. But in any case, critical path means the total float, generally speaking, this is not always the case, but to keep it simple, that generally means that your total float is 0. So if any activity slips even 1 day, the entire project is going to slip a day. That's what this critical path means, whether it's a critical path across multiple schedules or a single critical path for one schedule. So I think that's about everything I wanted to say on critical path. I don't know if there's any questions that came through. Let me jump back up into my agenda, but just to give a pause for questions.
Hey, Mario, can you show us again how you got near critical?
Yeah, sure. Yeah, I can do that. Let's go.
You just got to do it slowly, though.
Yeah, no worries. Yep. I'm trying to fit a lot in. I get it. Let me come back to here. All right. And let me go back to the view that I had.
So that's in a layout.
This is in a layout, yes.
And is it a
so-
canned layout? Is there one you made?
This is one that I made. Yeah. So if
And
anybody,
how did you make it? How did you make it?
yes. So if anybody's familiar with P6, this is the scheduling application that I'm using. You have the ability to set up and save these views that we call layouts. So how I built this, good question, was essentially the critical path I can just put on a filter, right, and show all of the critical activities from the start to the end, and that's no big deal. But then for my, scroll down to the bottom, so for my near critical path, this is where I had to go and sort of hunt through the other activities in my schedule and sort of see what float values there are that are above the critical path, and find
so
what
you're showing what you found. Your layout
Yes.
selects what you found. So
Correct.
there isn't a button in P6
No.
that says, "Oh, hey, this is the near critical path," or critical path, and that's important to know for me. Okay,
yes,
thanks.
that is true. Yeah. You'd have
Yeah.
to sort of uncover it yourself. That's true.
Right. Next question. Backward and forward passes.
Mm-hmm.
How do you do that?
So that's really, yep, let me bring back here. Yep, so that is, let me come back to this real quick here.
Well, I know the example. I just want to see
Yeah.
it in P6.
Well, P6 is all P6 does is this math automatically, right?
So
this.
So what
this
you're saying, there's no button for forward pass and there's no button for backward pass.
No.
It's an
P6
automated
is gonna
thing.
do, it's an automated thing, right? So what P6 is going to do is it'll take, like, let's just pretend that I click through all of these slides, one after the other, and it just does all this math. That's what P6 does when you press the schedule button. It just does boop, boop, and calculates.
Right. So when somebody says to me, "Show me your early dates, show me your late dates."
Mm-hmm. Yep, you can do that. That's pretty easy. Let me do that right here.
So you have early finish, late finish,
Yep.
as far as your columns, right?
Yep, that's it right there.
This
is where the float calculation comes from, right?
Yeah.
So what's the difference between these two dates, right? Depending on the calendar, it's going to be 12 days.
Okay.
Right there.
No problem. Now, my last question and I'm sorry, I'm kind of taking all your time. Do you use PERT to do your design of your schedule?
No, because since we're the owner, our schedules come from the contractors. So the schedule development is not what we're in the business of doing. It's more the review and acceptance of the contractor schedule. So how they come up with it, that's a good question.
So that now not everybody on this call is in your seat.
Yes.
They may need to create a schedule of their own.
Sure. Yeah. Mm-hmm.
And I started off with SureTrack.
Oh boy.
Way back.
Yes.
Like at the very beginning.
Mm-hmm.
And my boss always said, "Okay, here are the boxes. Connect the boxes," kind of like your diagram.
Sure. Yep.
And we did it.
Yeah.
And we did it in PERT view in SureTrack.
Yep.
And that became, it was only later that people said, "Oh, can you show me a Gantt printout, a bar? It's too difficult for me to understand all these other boxes."
Sure.
So we always defaulted to showing people in Gantt because they couldn't understand the PERT. But now we've gotten so far, we don't even write schedules in PERT. We've gone to, oh, let's create a bar. Let's put a link on it. Oh, let's create another bar. Oh, let's put a link on it. Oh, and so 2 bars, they don't make a right. It's just bizarre. So where have we gone? Have we not taught anybody how to schedule in PERT?
That's a good question. I don't know. I mean, that actually would be an interesting topic for a future webinar, actually, to sort of talk about the underpinnings, the creation of a schedule from scratch.
Starting
Right,
with
you know,
your
I-
diagram, starting with
Yep.
your simple diagram, that, and then you flip it and you show this is what that looks like when you have a Gantt chart. But look what you have gained by doing it in PERT. You understand these relationships, right? Anyway, just a thought. Thank you.
Yep,
I'm done. Thank you.
I'll certainly note that for, I don't know, Vincent, if you take that down, maybe that's something worthwhile to cover in a future webinar. No, I appreciate that. Thanks, Calvin.
No problem.
Okay, so let's kind of jump tracks a little bit.
Oh,
I want to
Mario.
go into. Oh yeah, sorry. Go ahead.
Sorry, we got a question from Cassie, if you don't mind.
Oh, okay. Yeah, sure. What's your question, Cassie?
Oh, Jesus. I thought you ignore us. No, I'm just kidding. Michelle has we have a whole bunch of girls and gentlemen and ladies over here. So there's 8 of us in this conference room. So Michelle has a
okay.
question.
Okay.
Yeah, hi. I have
Hello.
a question about the, just 2 questions. First one is on the critical path, you had some items as showing, float showing 1. Is that instead in lieu of 0? Is that
Oh yeah.
I guess my
Forgive me.
question is the critical path has to have the float for each line item or activity has to be 0. Is that correct?
Technically, no. I didn't want to complicate matters by going into it, but no. In this case, the 1 day of positive float that showed there, that's just kind of an anomaly of the calendars that are assigned to those activities. What technically determines the critical path is something we call the longest path. So let's say you had a deadline on your schedule, right? And that deadline was earlier than the date that you're scheduled to finish. You could end up with a situation where all of your floats are negative, meaning they're not 0. Let me bring this screen back. Like if I said the deadline of this project is the day 15 instead of day 20, then when I start the calculation on the backward path, I'd have to start with day 15 and calculate it backwards, meaning that this would be not 0 days of float, but -5, right? Because it's finishing on the 20th, not the 15th. So it's already negative. But that would mean that this is not only my critical path, but also the longest path. And same thing in the example that you saw with the +1 positive day of float. It's still the longest path, even though the float value technically is not 0. So it's kind of a, that's the thing that happens in scheduling. It's, I didn't want to complicate it by going through that level, but yeah, good question.
Okay, so if you have a negative float, then that means you should, I mean, you can probably keep it for however duration, but the goal is to make it 0. Is that correct?
Yeah, ideally, because as long as there's negative float, that means you're currently scheduled to finish later than whatever deadline has been set for you. Whether it's a deadline at the end of the project or a deadline on some interim milestone within it. Whenever you see negative float, that means you're behind schedule, and unless something changes, you're going to finish late. So does that mean add more resources? Does that mean resequence the logic of certain activities? Maybe you start materials procurement earlier than you otherwise would have. Whatever the case may be, whatever mitigation strategy, that's what would have to happen if you see negative float on the schedule.
Okay, and then just one more question about the multiple critical paths. So when you have like in your example, it looks like you have like projects within projects, right? But then you have a large project. Every one of them has a critical path. So does that mean there is going to be, like you said, maybe a longest path or another critical path that kind of connects all of those projects? And how do you determine that? Is that going to be first project finishes, the second one starts, or how do you? So can you show one critical path that summarizes, I guess, all of the critical paths, and how do they kind of, what's the relationship between those critical paths?
Sort of. So in the example that I have, because this is obviously the HART project that I'm working with, it's not as clean as what you're describing, but yes, that is possible. I'll try to show something close. Let me just open these back up here.
Concurrent.
So like we were saying before, each individual project has its own critical path, right? It's got its sequence of activities that from start to finish are going to determine when each of those projects actually finishes. So that was when I had this view. Let me go back here. Right, like here, yeah? So each of these projects, if I were to open it by itself and just look at its own critical path, would have a different set of activities than, let's say, this as an example. So what I'm showing here is that for this overall program, for all of what we call segment 3, that's the city center portion of HART, this is the critical sequence of work in the city center guideway and stations project, right? This is what's contributing to the longest path for overall city center work. But if I were to open up just the city center project by itself and look at the critical path, I think that actually runs through a different station entirely. This is coming through Kapalama Station over by HCC. This one actually would run through Kalihi Station a little further west, right back on the other side of Kapalama Stream. So these critical activities here are only critical in the context of the overall program, whereas this project by itself has a different critical path to its own substantial completion. That's the distinction I was trying to make, if that wasn't clear.
Okay, thank you.
Awesome, thank you. Okay, just looking at the clock here, let me grab one couple of other things that I want to get across. So until this point, we focused almost exclusively on schedule, right? Schedule. When are things happening? What's contributing to the finish date of my project? Where should I focus my attention if I want to make sure the project completes on time? But there's other factors that come into play here. So if I grab something like this. So this is a schedule, right? And it's got, same bunch of activities. It's got its start dates, durations. Let me bring these into view here. Oh, sorry, no, I hit those bars, my bad. So it's got, all these activities. What I want to take a look at now is cost and resources, cost loading, resource loading, right? So I have dollar values that are associated with each of these activities. Where those dollar values coming from depends on the project. In this case, they're coming from material resource assignments that are associated here. That in this case, this is a utilities relocation program. So, linear feet of pipe installed. It could be, manholes that are installed, sewer lines that are abandoned, and whatever the case may be. Those resources are all assigned individually across each activity. And what I want to show is in a view like this, where I have all my activities down the left-hand side. Let me see if I can show that a little bit. Okay, so here's all of my activities that are labeled with their activity IDs. I have the start dates and the finish dates for them. For this particular resource, it's assigned on all of these activities in these time frames. So I'm looking at it in this case by week, and so I can see there's 3 assignments of that resource in total for the week of November 20th, right? And if I scroll down, I can find what those 3 are, right? Something like here, there's 18 assignments of this resource across this time frame in the week of December 11th. 2 of them are here, 3 of them are there. In this case, these are crews. So I got 2 crews assigned here on this work. I got 3 of them here, and scroll down and you can find the others, etc. Right? So each resource assignment can be rolled up to show what the total allocation is of that resource throughout the life of the project. Yeah. This is a spreadsheet view, but I can also look at it graphically. This is one of the cool things that I like about P6. It makes it pretty easy to do something like this, where you take all those numbers, which, maybe some people's eyes glaze over. But if you put all those numbers on a graph, you can actually see here is the general allocation of in this case, my excavation day crews across the life of my project. This black line coming across the middle is what we call the limit. I've defined my limit here as, let's saying I have 4 day crews for excavation. I have 4 crews that can go anywhere across the project. And all of these green bars are where that allocation is fine. I have enough crews to cover that work. But wherever it's red, that's over allocated because, you know, I might have 5 crews worth of activities scheduled at the same time, but I only have 4 crews. So I know I'm over allocated here. So a view like this is something that could give, you know, whether it's a contractor or, you know, if you're like on our side as an owner, it can give you some insight into, you know, production rates, into where shortages might be happening if this was a material resource. This might give you some ideas on mitigation strategy if you're recognizing that you have negative float, we need to recover somewhere. Oh, well, you know, that's going to be difficult because I'm already over allocated on resources. I need to either, you know, hire more people, you know, bring in more crews. Do I need to, you know, dip out to the mainland for bodies? You know, maybe it's a material shortage, whatever the case may be. But a view like this can at least get those conversations started, right? And all this is just, I've got my crews assigned on whatever activities they're assigned on, and I'm just aggregating all this into a visible chart here, right? That's on the resources side. This is just looking at the resource allocation. You could do the same sort of thing with cost. So on the cost side, let me flip over to here. So same sort of thing. I have, let me actually take this to monthly. It's a little easier to see here. So on the cost side, you know, again, I've got activities that have a planned value cost. That was what they were originally baselined to be. And we have their estimate at completion cost. And those costs are distributed over time. So I can see, you know, for any given set of activities, what I expected to be doing in terms of spend at any given month, and what we're currently forecast to be according to the current schedule, right? As activities move around and things get delayed or you change relationships or whatever, right? So if I take this all the way to the very top, let me just come to the top line here. At the very top of the project, this is the summary for the entire project, whatever this project is. I'm not sure which one this is, but so you'd have at each given time interval how much money you expected to have to pay to deliver the work, or another way to think of it is what was the value of the work that was scheduled in this time period, contrasted against, in this case, the estimate at completion cost, which is, according to the current schedule, how much are we currently forecasting in terms of work to be done in that same time period. And you can see there's a little bit of a delta there, right? And similarly, just like we saw with the resources, like you have the spreadsheet view, which is that's certainly great, but you can also look at that in a graphical view as well, where you could plot the bars that are showing per period what are the early in the green and the late in the blue costs, right? So going back to our early dates and late dates, what's the earliest that activities can start and the costs that are associated with those, versus the latest in the blue that activities must start and finish, and the costs associated with them, and then chart those on a curve, right? So this green curve here is my total planned value for the duration of the schedule. And then the pink here is the existing estimate at completion, or the EAC, where this is the current forecast based off of progress to date, right? And then you can sort of, you know, draw distinctions between the difference between the two. You know, like one example, you know, sort of classically, you might say, you know, right here where my cursor is what is that? Like, it's like 8 point something, maybe 9 million something, $9 million worth of work if you just sort of look over here. And then you can see like the expectation is that we would have gotten to this point by here, but we're only here at this point, right? And the next time that, or the time that we'll actually reach that point is way out here a couple of months later. So that kind of triangle is one of the types of things you can do with a chart like this. And there's a lot more as well. I don't know if you guys have ever seen the monthly progress report that HART puts out, but all of the curves, the progress curves that you'll see in the charts that we put out on those reports, that's all based off of the schedule. That's all based off of the schedule. So there's more to scheduling than literally just the physical start times and finish times of schedules. There's also cost, there's also resources, and I didn't even get into things about, you know, being able to apply risk against your schedule, right? To have risk mitigations or whatever risk modeling that you want to have represented to give you a range of when activities can start and finish, right? Best case, worst case, and most likely scenario. That can be incorporated into scheduling and feed into your risk modeling as well. There's quite a bit that scheduling gets involved with, and that's really what I wanted to try to get across here. I know I went through a lot of stuff. I'm certain none of you guys are going to be expert schedulers at the end of this if you weren't already, but I hope that at least opens your eyes a little bit of what scheduling sort of comprises of and what it contributes to in a project. So I'll stop there. There's more I could go into, but I'm just looking at the clock. I want to leave time for questions. So that's all I got, guys. What questions do we have?
Mario, I have a couple of questions for you.
Sure.
One is, do you ever plug a formula as an activity duration instead of a fixed value?
We don't typically, but I could see how that would be useful. Yeah. Are you thinking of a particular scenario?
For example, a duration might be 10 days if you use one crew, or 5 days if you use two crews.
Yeah. So in the schedules, yeah. So in the schedules that we work with, no. But like in my previous job, I worked with an oil and gas company, and the limitation for their work was always the availability of resources on site. And so work would only take as long as it had to for the number of people that they could fit on board a drill rig at any given time, right? So in that case, you probably would set it, that would be called a resource dependent activity type, where you're determining the duration of that activity by the availability of the resources, not by the duration that you assign to it.
And my second question is related to the data date that you had mentioned. So that data date, you simplistically said it's the date that everything is calculated off of. Does that data date become locked once the baseline is established, or is there any reason to move data dates after you have a baseline?
Yeah, good question. Yeah, so the initial data date is going to be captured as part of the baseline. That's essentially the beginning of the project. But yeah, no, great question. I didn't get into this, but progressing activities, right? Statusing your updates on whatever frequency. For our program, we update every month, meaning every last Friday of the month is when this data date will get moved to the following month's Friday. And all of the work that was supposed to happen between those two Fridays, that's the period that we're updating for. So what actual progress we got made, what actually started, what actually finished, what's still in progress, what did we spend, right? What was the dollar value of the activities that did take place in that time frame? Yes. So over the life of the project, that data date is going to move periodically. In our case, it's monthly. I've been places where it's every 2 weeks, or places where it's weekly.
I see. So you can think of it almost as your calculator date, and anything that's happened in the past can't change. But when you go to recalculate the future, you're going to be moving that date incrementally.
That's right. That's exactly right.
Cool.
Yep. Very good. Thanks, Chris. Appreciate that. Looking at Vincent, did you have a hand up?
Yeah, I was wondering, how does this program interface with cost estimating programs? Like, are the values pulled from your cost estimate software, or are they entered manually, or how is that done?
It depends. It can be. So we use an estimating program here called HeavyBid, and there is a built-in integration between HeavyBid and P6, where if you build your estimate in HeavyBid and you've got all your quantities and what the total dollar values are, you can apply a couple of different settings. I mean, this is not my area, so I'm not a complete expert on it, but I've seen it done where they can set up the estimate and then essentially push that estimate out through an integration into P6, and it lands as it's not a fully formed schedule, but at least you have the list of all the activities and the associated values that come with them from the estimate. And so from there, that's sort of like a shortcut for whoever's going to build that schedule, because they already have all of the items that were part of that estimate, and then it's just a matter of sort of sequencing them together in what makes sense for the job to be done. Like I said, I'm not an estimator, so I'm sure there's a lot more that goes into it than that. But no, you're not restricted to just painstakingly manually adding activities one by one. There are ways to do integrations to bring detail over from an estimating software.
Okay, thanks. And my second question is, as a scheduler, do you have to know all this stuff that goes into the schedule? I mean, it looks quite complex. And how does somebody get started in scheduling, in what you do with, very limited knowledge, right? And develop a schedule like you're scheduling. I mean, it seems like you have to know a lot about construction. You have to know about cost estimating. You have to know about various different subject matters. So how does one go about that?
Yeah, I'd say having a deep knowledge of all of those areas certainly helps, but I don't know that it is required. At least insofar as my experience as a scheduler. I like I said, I came from Oracle, where I mostly did software implementations for 16 years. So coming here to HART, I certainly didn't have a construction background. But I'm still able to schedule pretty effectively, or at least, in HART's case, we're not the ones developing schedules, but analyzing schedules, because I understand, like we went through in the PowerPoint presentation, I understand the logic between activities and how those play with each other to determine the float values. And so, if something looks like, wait a minute, these activities here with this resource allocation, let's say, I don't need to know very much about what excavation is to know that, okay, there's no way you're going to be able to deliver the work you're telling me you're going to deliver in the time frame you're going to deliver it, because you're over allocated. Your crews can't handle it, right? I don't need to know anything about construction to be able to know that. It certainly helps, right? And you can go to that next level of detail and really start thinking of solutions, let's say, to issues that might be facing a schedule. That could certainly help, but I wouldn't say a lack of industry knowledge is necessarily a barrier to entry, right? As long as you understand sort of the fundamentals of what a schedule is and how that interplays with the resource assignments and the costs and that sort of thing, that's a good place as any to start, for sure.
So the information that was shown, I guess, in what you call the layout section, with all the different tasks, did you have to develop those tasks yourself, or did somebody like a contractor provide them to you?
Yeah, in our case, that was developed by a contractor. Let me just go to a view like this. Yeah, in our case, that was developed by a contractor. Excuse me, with oversight from us. So it was, we were certainly involved in the review and approval process. But there have been times where I've developed a schedule from scratch. It wasn't as elaborate as this, 1,100, line item schedule. But as long as you have, some subject matter experts in the room that can tell you, like, here's the things that need to be done. And if you as a scheduler are savvy enough to ask, okay, so you need to do these 3 things, are there any dependencies between them, right? Does one need to finish before the others can begin? Can they run in parallel? Do they need the same crews to work on them? What about materials? Do we have materials that are ordered in time for that work to start on, on whatever date that we're trying to schedule it for? Like you can sort of, work with the people that are subject matter experts and develop a schedule from scratch, for sure. Yeah.
Okay. Hey, thanks, Mario. I think we're at 1 o'clock right now. I guess if there's any last questions that somebody wants to ask, and then we'll adjourn after that. All right. Looks like we're all out of questions, Mario. I want to thank you for taking the time to share your knowledge with us and speaking on this topic. And I certainly learned a lot. So thanks very much.
Yeah, thank you. I appreciate you guys joining. My email is as part of my signature. So if anybody has questions in the future, feel free to email me. I'm always happy to help out. Appreciate you guys showing up. Happy Friday. Enjoy the weekend.
All right. Thanks, everyone. See you later. Bye-bye.
Thank you, guys. Bye-bye.
Thank you.
Thank you.